In this video, we're going to look at the next type of factoring method, and it's going to be slide divide bottoms up. Okay, this method isn't correctly named. However, it's something that I think is easier for y'all to remember. Also, it's a lot easier than the way I was taught in school, so I think just to simplify things, that it'll be a little bit easier for y'all. And again, if I can make y'all's life easier, why not? Okay, so again, just like with greatest common factor, if you have an equation, make sure it's equal to 0. If not, and it's an expression, there's no equal sign, you can proceed to step 2. Now, you're going to need to label your A, your B, and C. Well, what exactly is A, what is B, and what is C? Okay, fair enough. A is what is raised to the second power, okay? Or it's the number beside x that's raised to the second power. B is beside the variable with an exponent of 1. C is what we call a constant term, or it's just a number, okay? Now, slide really means multiply. So you're going to multiply your A and C. You're going to then find the factors of step 3, or A times C. And you're going to pick 2 factors that that multiply to equal A times C, and then add to equal your B term. Okay? And you're going to place those factors in. So you're going to place in front of your factor, so you're going to place your x and factor and then you want to divide your factor or your constant by your original A value, and then you want to simplify it. And then if it can't be simplified, or you simplify it as much as possible, you're going to bring the bottom, or what you're divided by, up in front of your x. So explaining it's just by words is kind of difficult to look at, but I'll go through some examples on page 17. So I'm actually going to do a harder one. Okay, so when you do this, the first thing you need to do is label your A, label your B, and then label your C. Remember, A is what's raised to, is a number that's raised to the second power with your variable. And here I've changed it up, right? I don't have x's, right? A variable is just any letter. It's a placeholder. B is the number beside a variable that has an exponent of 1. If you don't see an exponent with a variable, assume it's 1. So B is equal to 19. And C is just your number. Okay, so C is just 12. So from here, I need to multiply AC. So A times C. A is 5. Multiply times C, which was 12. And I'm going to get 60. Once I do this, I need to find all of the factors of 60. Okay, so I have 1, 60, 2, 30, 3, 20, 4, 15, 5 times 12, 6 times 10, 7 is not 1, 8 is not 1, 9 is not 1, 10 times 6, but if I look back here, 6 and 10, right, 6 and 10, 10 and 6 are the same two factors. In the next example, I'm going to show you like a little shortcut to show you how many factors you actually need to find so you don't find repetitive factors. All right, but anyways, A times C is 60. I need to now find two of these factors that add to 19. Well, 1 and 60 is 61. 2 plus 30 is 32. 3 plus 20 is 23. 4 plus 15 is 19, so this works. 5 and 12 is 17. 6 plus 10 is 16. 10 plus 6 is 16. And again, it was repetitive, so I'll just mark it with an R. So I'm going to now have 4, 15. So this is where I kind of stumbled in the explanation. So once you find two factors that multiply to give you 60, add to give you 19, or your B value, you then set you up two sets of parentheses. Okay, you then put your variable at the front of the parentheses, and then the signs of these factors needed to get to B. So both of these were positive in this case, n plus 4, and then n plus 15. Now here comes where your divide is. You're going to divide the constant of each factor by the original A value and simplify it. So 4 divided by 5 is 0.8. It's not a pretty number, so leave it alone. N plus 4 over 5. 15 divided by 5 is 3. Now here comes where your bottoms up is going to come into play. If your bottom, or if your number and what your original A was, and you divide it, it's not a pretty number, then what you divided by, or your original A, just move it up in front, make it a coefficient of your variable. So 5n plus 4 times n plus 3, and then this is your answer. Whoops. Okay. GCF, definitely easier. And again, this is one of the harder examples. Now let me do an equation. I'm going to do the one right beside it because we're actually going to have some positive and negative factors here. So in this example, again, I see an equals 2 sign, so I need to think, okay, well, I must get one side equal to 0. I can move everything from the left to the right, or I can move everything from the right to the left. It does not matter. Okay, I'm going to choose to move everything to the left because it'll wind up letting me have 3 positive things or 2 positive things versus two negatives. Again, it doesn't matter. So negative 5x squared, I can move it to the left by adding. When I do, I have 5x squared minus 18x equals negative 9. Again, it's still not equal to 0, so the opposite of negative 9 is plus 9. Then I have 5x squared minus 18x plus 9 now equals 0. So I can actually start the problem. Also, if you notice, the correct way to write polynomials or any kind of function is from the highest degree to the lowest degree. That's why I put the 5x squared in front of the minus 18x. So again, once you get it set equal to 0, find your A, find your B, find your C. A is always the coefficient beside your x squared, so 5. Your B is always the number to the left of your variable with an exponent of 1. Here it is important to take the signs, okay? The only time I take the sign is if it's a minus, just to let me know. So negative 18. And then my C value is just my number or my constant. And it was 9. Okay. So after I identify A, B, and C, you want to multiply A times C. So 5 times 9 is 45. Now that trick I was telling you is you want to actually take and find the square root of AC. Okay. So the square root of 45 is 6 point something, right? 6.8, 6.9. What this is going to tell you is you go up in factors to this number, okay? You don't go past 6. So 45, I'm going to find those factors. 1 and 45. 2, it's not even, so it doesn't work. 3 and 15. 4 doesn't work. And remember, a factor divide, or a number is a factor of a number if it divides and you don't have a decimal. 5 and 9. 6 is not a factor. And then again, I get to 6 and I'm done. So I have to find two numbers that can now add to get me negative 18. Well, 1 plus 45 is 46. 3 plus 15 is 18. If that was negative 18, that would be great. So I'm just going to put, a highlight here, because the 18 interests me even though it's negative. 5 plus 9 is 14. It's close. So when I tried to have both of my factors be positive, I did not find one or find a pair that give me negative 18. So now what I'm going to do, both of them were positive. It's okay if both of them are negative. So negative 3, and again, it must add. Negative 3 plus negative 15 is negative 18, and that works. Again, the signs do not matter. One factor can be positive, one factor can be negative. Both of them can be negative, both of them can be positive. Sometimes, the left want to be positive, the right want to be negative. Sometimes the right want to be positive and the left one negative. It's going to vary depending on the particular quadratic, okay? So then, since I've found my two factors, I'm going to set up two sets of parentheses. My variable this time was x. Then I said minus 3 was a factor, and then minus 15. Now my divide step. So my original a value was 5. So I'll divide both of those by 5. X minus 3 over 5 is not a pretty number. So I'm going to skip a step from the expression. Because it's not pretty, I'm going to go ahead and bring it up. So 5x minus 3. And then 15 divided by 5 is 3, but this negative keeps it a 3. And x goes in the front. A quick note. Every time a slide divide bottoms up, if you have done it properly, one of the factors, okay, or one of the numbers at the end of your set of parentheses is going to reduce to a pretty number when you divide by your original a. If it does not, then you've either A, chosen the wrong factors, or B, you have made a sign error somewhere in your original, through your work up to this point. Once we get through the next type of factoring, I'm going to actually, and this is equal to 0 because it's an equation, but I'm going to show you a couple of shortcuts and tips on factoring quicker and double checking your work.